recording started. All right, so we have to finish. Today was supposed to be the first class of around the notion of equilibrium, another keyword in the foundations of economics, a word that economists use all the time. It requires a bit of clarification, but we have left a very important piece behind when talking about production. That is, we have left behind exploring, at least partially, how economists talk about and have been thinking about technological change. So we should dedicate a good part of today's class to that aspect. So in some sense, production, or if you want technological change, will take 3 lectures. And I think we can handle equilibrium with a little bit of a mention today at the end of the class in talking about Marx's analytical setting. And then on Tuesday next week, by focusing on the specific theoretical characteristic of what the economists call equilibrium. If there is anybody here, just to be clear, and to say it once, I will say it again, if there's anybody here that has some familiarity with the word equilibrium in the natural sciences, economists do not use it in that sense. Equilibrium in the natural science is typically a position of rest of some underlying dynamical system, that it's what we call a stationary state. Equilibrium in economics is simply a situation in which the various parts involved in a game, or in a game, believe that what they're doing is the best response to what the other people are doing, and do not change their action in that moment. Along an equilibrium path, that's why we call them equilibrium path, people may change period after period after period, their behavior and quantities may change and everything may change. There is no reason for an equilibrium to correspond to a rest point in any sense. But we will see that more clearly after finishing on technological change. So let me share this with you. Where is it? Here it is. So this is class number 10, and you'll find it in the usual spot. So the idea of technological change is to go from one activity to another. What does it mean? How do you do it? Why do you do it? When do you do it? So what does it mean? It means, as you will see, this became clear only in the early years of the 20th century. It means you change something, anything. Technological change does not have to be gigantic, does not have to imply the discovery of nuclear energy or of airplanes. Technological change is anything that alters the condition of production. You see, from this point of view, it helps a lot to be very strict, as we were, in defining the activities of production. Because once you realize that a proper specification of the activities of production enables you to understand that producing things requires a whole sequence of steps. And in all those steps, there is always some demand of some factor, some supply of something, and there is some relative price popping out somewhere, even if it is a very minor thing. In our example of the mochas, it could be the price of gas. And now the amount of gas we consume in preparing a cup of coffee is obviously very small. But it's also true that if I prepare coffee for 4 people using 2 mochas of size 2, I consume a bit more gas than if I prepare coffee for 4 using a mocha of size 4. So this is what we call technological change, going from mocha for 2 to mocha for 4. Deciding they adopt a new technology, a different technology. It doesn't have to be new, a different technology to produce something. In this case, the same thing, coffee. Okay? This has an effect on relative price, because even slightly, it reduces your consumption of gas. In fact, it also reduces a bit your consumption of coffee and water, but we will not. And obviously the amount of time it takes, because you can do everything again in 7 minutes or 7 minutes and a half, maybe 8, because it takes a bit more time to put the coffee in the mocha for 4. And you save quite a bit respect to the case in which you use the technology for 2 coffee machines. Now you say, well, my God, this is very boring. Yes, but think, that's the what part. Episodes of this type take place every day, thousands of times all around. I will go back to Schumpeter later, but this is clearly Schumpeter's greatest observation, and it's such an obvious observation, right? Noticing that every day, hold on a second, I think they are calling here at the door. Every day, in thousands of different economic activities in a country and around the world, people do things slightly differently from yesterday, even for minor inputs. That's technological change. One of the reasons why prices are not constant over time, one of the reasons why there is an enormous degree of unpredictability, it's not coming out, unpredictability in economic activity is exactly this. The people change what they do extremely often. And even if they change in minor details, the minor details accumulate. So the what is this? How do they do it? Well, they do it, as I said. People like to make a lot of distinction about various types of technological change. If you read the business literature, the technocrat literature, the literature of people that do business administration, production, they classify all kinds of technological change. And for many purposes, this is very useful, right? If I am trying to quantify if a process of technological change favors some type of work as opposed to another, it's useful to know that I'm replacing nurses with computer programmers, right? Which I am, by the way, in some jobs, right? To the extent that a lot of testing is now carried out by machines that have an electronic software component. That's actually what I'm doing. I'm replacing biologists and chemists and medical personnel with computer programmers. Sure. So I can do all kind of classification of technological change. But when you look at that from the point of view of economic theory, it's quite obvious that there's only one kind of technological change. It changes one of the entry in the activity. That's it. Could be I produce a new chemical, I produce a new kind of bread, I produce a new type of shirt, a different color, a different cut, I use a different type of textile, whatever, different type of labor. In any case, what I'm doing is I take an activity or more than one and I change some of the components. That's very abstract, obviously, but at the level of the theory, that's the level you want to think of. And then you go down to the application, but the application are history dependent, right? They're history dependent because technological change has changed. The type of things we change today are not the type of things we changed a century ago. The introduction of the steam engine obviously changed certain methods of production in certain ways. The introduction decades later of the electric engine had a completely different impact, right? And so certainly in studying the history of technological change, these more detailed description are very useful. But if I look at it from the point of view of theory, how does it take place? It takes place by changing one or more entry in one or more activities, period. Why do you do that? Well, I think the economist answer has always been the same. It's been because it's convenient. That's it. That's why you do it. And on this, economic theory has been extremely ambiguous. As you will see, economists have started to talk seriously about technological change and analyze it specifically only in the 20th century. And as a matter of fact, in a serious way, only after World War II. This is actually one of these things that from the sociology, from the point of view of the sociology of science, is very interesting. I will mention it later. That is that academic economists and professional economists in general have started to pay systematic attention to technological change only very late, without realizing how crucial it was before, okay? But in any case, there are two answers. One, as you will see, and I already mentioned, is the silly answer. It happens because it happens. It comes from the sky. It's TFP. It's some miracle from the sky. Scientists take care of it. It's something that happens in universities, then we use it. Clearly, we have learned by experience that this is not an answer. It doesn't even make sense because it doesn't happen in the universities. It depends on the relation the universities have with the economic activity. It depends on millions of other things. And it doesn't happen automatically from the sky, independently from economic activity. But the point is that we observe every day that it depends on convenience. People innovate, people change the way they do things because it's convenient. And sometimes the reason it becomes convenient are extra economical, even if at the end they're all economical. So in fact, what we're doing right now using Zoom is a very good example, right? This object, this software called Zoom exists since November 2011. I learned about it in December 2011 from one of the guys working at Zoom at Stanford, okay? And started using it in January 2012. People that know me knows that that's the case because I've always used it. It's been evolving a lot. The very first edition was a lot simpler than this and had fewer features, but it was always very good and always better than the competition, just to be very explicit. But I abandoned Skype back then. And it's particularly useful for doing the kind of things we do. In particular, it's very useful to do intellectual work in small groups or to give big lectures to a very large number of people, okay? It's not very good for teaching, which is why today we had to make an exception, but in general, it's good to be in class. It's not good for teaching. It's not good for teaching unless there is a very small group, 4, 5, 6, 8 students, you know each other very well, you interact and so on. But for doing research, for example, it's fantastic. It's fantastic. You know, you just work with your people and so on. Nevertheless, and so in a lot of activities, clearly video conferencing via Zoom and its imitations, it's extremely convenient. Saves time, saves money, saves troubles, blah, blah, blah. But hey, most people didn't even pay attention, didn't even realize it existed until the pandemics, right? 99% of the people that today use Zoom and even use the word Zooms the same way you use Xerox, right? Let's Zoom, which means let's just have a video conference. Maybe then you use something else, but you call it a Zoom, right? Like people say, let's Xerox it, and then they use a Canon machine or a Minolta, whatever. Right? Didn't know it. And why was it so widely adopted and spread out since February 2020? Because of convenience. It suddenly reduced enormously the cost of doing things. And it was an economic cost because traveling and interacting physically and having the risk of catching the virus when you knew nothing about the virus and you had no medicine, no vaccine, was very costly. So sometimes, adoption of an innovation is driven, this is a perfect example, by shocks, by events that are not easy to predict. Sometimes it's just predictable in some sense. Di nuovo sono qua. Susanna. Sorry, I have people at the door and scusate, sono tornato in albergo ovviamente per fare la lezione e purtroppo arrivano a bussare. Okay. So as I said, sometimes it's a big event, sometimes it's a small event, but the point is that it's always a matter of convenience. Sometimes it's very predictable, right? Once a product becomes almost standardized and there is a routine research and development behind it, and there is a very clear competition among a number of players, again, PC, all the electronic, telephone, and things like this are perfect example, then we know that there is, as long as you are within the set of predictable stages, there is a kind of routine innovation process. Now with Cell, it's become a bit like fashion. You know, in the fashion world, every year, every season, every fashion house presents its new collection. It's automatic. Sometimes it's pseudo innovation. In fact, most of the time it's pseudo innovation, but they have to do it. In the car business, in the cell business, and so on, the same is true, right? Every year there is a new model, or every 2 years there is a new model. And that's driven a lot by strict pricing, cost, and competition condition. But obviously there is also an underlying strategy of picking some characteristic and try to modify them, as opposed to picking other characteristics and try to modify them. In fact, when you think deeply at why people innovate, you realize that in the popular description of what economic competition is, in the popular chit-chatting about a competition, and also in the technical one, for example, behind industry organization and regulatory mechanism and antitrust and so on, we think at competition as the instrument or as the condition to cause technological change. In fact, we think that competition and technological change are the same thing, right? If in a neighbor, a bar introduces an event that attracts people at night, and so billiard room, come to the billiard room, happy hour, right? Then, and that's successful, well, that's technological change. And the other bars in the neighbor that notice that the happy hour at the billiard is a success will do the same. They will create maybe a different type of a happy hour, but they'll try to imitate. They also, that's just adoption. That's nothing but adoption. If pizza made in a certain way is successful and takes away client from me, I will try to imitate that pizza. And that's why you observe these patterns in every industry, in every sector, in which there is some change, that somebody moves first, then the other guys imitate. In fact, if they don't imitate quick enough, they die. Think of all the bookstores around the world, they didn't imitate Amazon quick enough and they died. It's very simple. When Amazon started, they were a small bookstore in Seattle, Washington. They were not a $1 trillion company. They were literally a relatively small bookstore with two good manager and a computer and a program. And they started out doing very simple things. They did not have drones. They did not have airplanes. They did not have Federal Express working for them. None of that. The other bookstore didn't imitate. So the initial technological change by Amazon was very small. They changed some of the inputs in the technology that delivers books to the readers. That allowed them to be very successful, to energize other resources, to collect other resources, and progressively they grew. And they changed as they grew. Competition there, even if it was clearly possible, did not lead to imitation. And we should ask also why, right? One could say, oh, that's a good proof of irrationality. Sure, maybe. Or it's a good proof of something else. Underestimation, misunderstanding of the way things were evolving, non-knowledge of the technology, whatever, a variety of things, clearly, but it's still a great mystery why no chain of bookstores in Europe or United States said, okay, I'm going to beat Amazon on its own game. Point is that Bezos didn't do it because he wanted me and you and everybody else to read a lot of books. He did it because he wanted to make money, and he did. Okay, so that's why. And when? Anytime. And I will not belabor further on that. One interesting thing of technological progress is that it takes place every time, anytime, every morning. As the example of Zoom shows, is that economic theory is not about invention, but it's about adoption. This is something that Schumpeter, JES, is Joseph Alois, depends how you want to pronounce it, Schumpeter, okay, JES. And he insists on this. He says, look, the point, from the point of view of economists, it's not to figure out how a scientist comes up with an idea. Because that specific ability of the human mind to create variation, to perturb, to imagine different ways of doing things, it's fascinating, it's very interesting, it's something cognitive scientists, psychologists, neuroscience should study, but economists have no tool. We just assume and take into consideration the fact that humans do that. Humans have this ability of reacting to circumstances, to stimuli, and say, I'm going to do this different. They turn the circumstance into a problem, and then they go problem solving. They don't solve the problems all the time. Many problems remain unsolved, but we solve them. And how we solve them is not predictable by economic theory either. It's not predictable by economic theory. Economic theory has nothing to say, seriously, about what's next invention, right, in digital communication. No idea. The interesting thing is that before Schumpeter, there is very little. Hundreds of years of economics, hundreds of years of people thinking about economic exchange, what's just, what's not just, how you become wealthy, international trade, how income should be distributed between workers and capitalists and farmers and landowners and the state, all kinds of things. But technological change, very little attention. Very little attention. In fact, what the thing that clearly the first economists, even those I mentioned at the beginning of the lecture, the Italian one in 1500 or the Spanish one in 1600, or again, the Italian and the French and the Scottish in 1700, are mostly impressed is accumulation, the enormous growth of commerce. They kind of talk about technological change because that is also technological change, right? Having merchants that instead of restricting themselves to a city or another, start moving around progressively year after year, century after century, are capable of organizing big trips, are capable of using new ships, and new ships come around and you can make them bigger and you can travel farther. That's technological innovation. But somehow it's not perceived as that. There's no thinking about the technique part, because there is not a model of production, as we said a week ago. Matter of fact, there is not a model of production, and the classical economist until Marx, the focusing on production is essentially restricted to, where does value come from? I already said this, right? But this is just to make you understand why they were not focusing on the technology side. Even if they were stumbling upon it all the times, right? After all, think about comparative advantages. Comparative advantage is all about technology, right? Ricardo could have come upon that and said, oh, wait a second, and then what if technology changes? And they kind of say that because he does mention if the terms of trade change, if the comparative advantage gets modified, but it's not thought systematically as a theory of production, which is okay. I mean, this is not to say that Ricardo was dumb, but Ricardo was very smart. It's just that you discover things and you build up tools of analysis one step at a time. Not everybody can, you don't come up with things right away. So clearly, to understand these days, I'm sure when people teach comparative advantage, what is that they do? Well, they write two activities, right? One for cotton and the other for wine, or one for textile and the other for wine. And the variable factor is labor, and you say, oh, it takes so many units of labor to produce this one, blah, blah, blah. You use that. So you use a modern tool that Ricardo kind of has in mind, but doesn't make it explicit. So the point is that until Schumpeter, most economists do not pay attention to the technological aspect of the thing, focus on the fact that wealth comes from continuous accumulation. So that's what they notice. And again, don't be surprised, right? Because clearly, if you think at the technology people use, saying in 1800, the very beginning of 1800 or 1750, and you compare to that of 500 years before, what is that you notice? You notice that it's a bit different, but it's not remarkably different. So just a moment before, the steam engine gets adopted widely. Now go read some history book. Look at the description of what people would do in the countryside, in the farms, in the small factories, in the put-out jobs in 1770, in the mines, when there were very few steam engines around, very, 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 very few. They were a rarity. James Watt had just patented his own version with Boldrin, and they were producing very few. There were some old steam engine using the other technique, the French guy with the S, I forgot the name. There was another technique with our external condenser. Okay, it was much more efficient. It was used a little bit in mining and nothing else. Okay. So in that period, if you look at what people are doing in economic activity, what is it you note? You notice that farming was not so different from 600 years before, 700 years before. Navigating the ocean, yes, they were using different ships, more masts, different organization. They could go very farther. They'd grown in size and in some of the underlying technology. Now they had maps of the world, the world better. They had, what's the name? Sorry, I forgot the name of two instruments, so they're not coming to my mind. It's going to come in a moment. But it didn't look so different. There was just much more. Everything was bigger. The cities were bigger. There were more people around. Trade was bigger. Cultivation was bigger. But when the merchants had to go from the countryside to the city to sell the goods, they still had to take the oxen or the horses, put on the cart and push and travel, exactly like they did 1,000 years before. You still had to move with the horse. In the house, the light was obtained by fire, by burning something, and so on. So there had been technological change. It was very small, but people had not paid a lot of attention. For example, people had glasses on the windows, things of this kind, right? Obviously, there was typographical activity. So there was small technological change, but it was not very visible. And so people don't notice. The thing they notice is that everything has become bigger, gigantically more trading and commerce and production and things of this type. That's why they focus on that. And then Schumpeter comes at around 1900 and says, hey, wait a second, you dodos, don't you realize that we live so much better than they did only 100 years ago? Don't you realize that most of us live a lot better than 100 years ago? And you think that that comes from accumulation? Don't you think that slowly but surely everything has changed? And the reason we live so much better is because we have drastically changed the way we produce and do things. Is by far the first that points that out. There is a bit of it in another guy, we'll talk later, which is Marshall. You should also, if you're curious, you should read Marshall. Marshall has an idea of innovation at a micro level, but he's mostly concerned with what the innovator does, economically speaking, at the micro level. He doesn't seem to be very interested in discussing the macro implication, the general equilibrium implication of innovation. So Schumpeter throws the topic in there and writes a lot of interesting things about that. Between 1910, 11 and 1930, 35, he writes a lot of interesting things. Almost alone, almost lonely in doing this. And then the whole thing is forgotten. The whole thing is forgotten. So people, if you look at the literature between 1910 and the end of the war, you will find very little about technological change, very little. So you have this solitary figure that says, look, we have to study innovation. We have to study entrepreneurial activity. We have to study what motivates, how this continuous change of techniques, change continuously relative prices. So we never come to a rest point. And so the equilibrium, the economic equilibrium keeps evolving and moving and changing and changing. There is no stationary equilibrium. And he goes on and he tries to explain business cycle in that way and so on. I cannot give you the richness. I really invite you to read the books of this guy, particularly Theory of Economic Development, and which is relatively short. And you should also read the first 3-4 chapters. The rest is not so crucial. So it's relatively easy reading, and you should definitely read it. It's even easy to find for free. The PDF is around. The other book you should read, even if it is a bit more boring and certainly a lot longer, is Business Cycles, because it clearly makes a big effort, given the analytical ability of the time, to tell you stories of how continuous innovation is probably the driving force of business cycles, of economic oscillation. Not of all business cycles, not of all economic oscillation, but a good part of them, a good part of them. But interestingly, he's almost alone. There are a few other guys that do it quantitatively, Slutsky. But what happens in those years is that everything is dominated by the Great Depression. The Great Depression becomes the big event. People, in the late 20s, first there is the World War I, then there is the Great Depression, and the Great Depression made people, in some sense, forget, ignore the big changes that had happened in the century before. They're all concerned about, oh my God, we've become suddenly all very poor, there is unemployment, blah, 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 what do we do? So the Keynesian theory comes in, the debate starts being about government, not government, how do we overcome unemployment? Then the World War II comes. And after World War II, then people start realizing that. And in this, Solow and Mead and others are very important because they come back to Schumpeter observation and they say, wait, look, there is still growth. We're back to growing. And growth is driven by technological change. But they do it at the macro level. You see, Schumpeter had this incredible ability, which I think that's why the guy had a better vision than many of us, that he would start from the micro observation of what the firm does, what the entrepreneur does, what the innovator does in this or the other instance, but then he would be able to put it all together. You need to have the ability to see millions of people doing that thing and realizing that they are interacting. And then it's this interaction of these millions of different people that creates the new equilibrium. Maybe because he did not have macro data good enough, he gives this example, and they're all micro examples. Also in business cycles, he doesn't really have good macro data, but so he tells you this story about that industry, the other industry, that sector, the other sector. After World War II, there are more macro data, particularly for United States and United Kingdom, and people pay attention to that. And there is the famous, everybody knows, Solow TFP exercise. Okay. What is the solo does? I'm not going to explain TFP here, right? But for those of you that have never seen it, solo does, let me take away this actually for a bit so I can explain by moving my hands. What is the solo does? Solo says, I have the national income accounting. Everybody can do this on their own at home today with Excel. It's very simple. At the time, it required a lot of effort, but now you can do it in 1 hour with Excel, right? You go to the national income accounting, the yearly data, you can do it quarterly, it's the same. You get GMP, hours worked, stock of productive capital. You can use machine and equipment, construction, or just estimate of the capital stock, okay? And his argument is, if technology is constant, if the aggregate technology is constant in the sense of the overall collection of all the technologies people use, if output grows, it must be because of accumulation, right? Because there is more K and more L. More workers, more hour work, the more machinery, more equipment. So I can compute the growth rate of output year after year and discover is 2.5, 3.7, 1.9, 3.7, 3.9, 6.4, right? Compute the growth rate of labor and compute the growth rate of capital. If the technology is constant, the growth rate of Y must be, you remember the aggregate production function, right? Must be some mixture, some weighted average of the growth rate of the other two. A little bit grows because there is more labor, a little bit grows because there's more capital. Very logical, very simple. It's in fact exactly chapter 2 of Schumpeter's theory of economic development. It says, look, think about, you think that growth comes from saving, investment, accumulation? Okay, let's think about it. Look at stationary societies where there is very little technological change, and imagine growing just because you accumulate a bit more of that stuff. How fast would you grow? It's just observation, empirical observation suggests you would not grow nearly as fast as we've been growing. You probably would grow 1/10 of the speed. Right? So Solo does the same exercise. Now, he has to put weights, and here lots of people debate, lots of assumption. No, because this is an exercise that is made by contradiction. It's an exercise that wants to shock you. So it doesn't really matter which weights you use. He decides to say, well, assume everything is competitive, we're in competitive equilibrium, prices are exactly equal to marginal productivities, blah, blah, blah. Very extreme case, right? Prices are equal to marginal productivities, and so I'm going to use this idea that marginal productivity equal wage, and marginal productivity of labor equal the wage, marginal productivity of capital equals the return on capital, and therefore I use the Euler equation to decompose. Frankly, you can, if your argument is trying to get an intuition of what's going on, you don't need all that, You need simply assume that output does not grow more than proportionally than inputs. That is, what is you need to assume from last class? What? Right? I'm assuming, yeah, go ahead.
Yeah, about returns to scale.
Right. It's just that there are no increasing return to scale. Right? All you need to assume there are no increasing return to scale. Because if there are increasing return to scale, then sure, output may grow 3 times more than inputs. At that point, the relation between how much the inputs grow and how much the output grow kind of blows away. Because if there is this increase in returns, who knows? Maybe just by doubling capital, productivity of capital goes up by 10. So output explodes. And this also should make you think that, in fact, increasing return has always been a little silly trick to hide technological change. Right? But so if there are no increasing returns in the aggregate, then you compare the two growth rates, the two groups of growth rate, the growth rate of GDP and the growth rate of capital and labor. Or you can decompose, many people can decompose, you can decompose many type of capital, it's okay. Machine, equipment, construction, public capital, right? And you can also decompose different types of labor. To the extent you have data, you can do that. Still, even if you have 22 inputs, at the end, output has to be a combination of the 22. And so if output is regularly bigger than the biggest growth rate of input, Filippo, I saw you raise your hand. Please go ahead.
No, I just wanted to say, but still, assuming increasing returns to scale, it's still useful for the sake of models, right?
No, in this case?
Well, I mean, in general, for economic theory, I mean, for macroeconomic models.
I don't think it's very useful at anything, but it might be. First of all, I have a huge problem by using something that I clearly can never point my fingers at. I have to admit on this, I'm a bit of a realist. Even in philosophy, I tend to think, okay, so you say there is the essence of eggs, and you know something about the essence of eggs. I'm joking. So can you point your finger to the essence of eggs? Right? But leaving aside philosophy, if people say, I'm going to explain that with increasing return, I say, good, but you have to give me an example. One, all I need is one. You see, the cup of coffee is a good example of constant return. I can give you many examples of constant return. Notice there are some examples. For example, today we have the minimum number of students connected. We have 20 people. If 27 students were connected, would we be using a different technology, or would we just be using the fact that this technology, the video conference, has increasing return within a certain segment? I tend to think of the second, right? Because yes, let me use 20, 30, so it's simple. If instead of having 20 people, there were 30 connected, we would have 50% more student time. So from the point of view of student time, there would just be an increase. As an output, we would have 50% more student learning, hopefully. Assuming that the 10 new guys were on average, more or less like the 20 that are here, we would have probably the 50% increase in output. So one can say that's constant return, 50% more student time, 50% more student learning. But electricity consumed would not increase of 50% because my electricity would be the same. Right? Yours would go up 50% because everybody would have to turn on their video and their speakers and blah, blah, blah. Probably bandwidth consumption would not go up 50%, okay? And certainly the expensive factor here being me, my time would not go up 50%. And to the extent that people don't ask a lot of questions, and to the extent that, people don't talk in class. So for example, in class, this is not obvious, right? As class size increases, it becomes much more difficult past a certain level to teach because people make noises, they distract, there's a lot of, so the learning goes down. You really change technology. But in video conferencing, up to a certain number that we can manage on the screen, no. So this is an example, in my opinion, of increasing return. The question is, how general is this example and how relevant is it in explaining output growth? You see what I mean? That's so So let's put it another way. Another way of looking at this, but this we're going in advanced micro, and this is not the purpose of the course. But one way, the way David and I think of this is that every technology has its efficient minimum size. So Zoom is clearly the efficient minimum size of teaching via Zoom is not one-on-one. 1 on 10, 1 on 20 is probably better. I'm not sure 1 on 50. But so there is an interval of increasing returns. So the relevant empirical question and also theoretical is how general is this? And how much does this explain of growth? Right? How much does this explain growth? So modeling the transition from the old Nokia phone to the smartphone. Should I do it by using increasing return, or should I do it by saying there was technological change? To me, it's almost no issue, right? Obviously, it's technological change, for Christ's sakes. What is the increasing return there? You see what I mean? Or in going from the old, I'm in Rome, as you know, so from the old Settebello, they used to connect, it was called Marco Polo, the Venice with Rome back when I was your age, to the train I took today. Was there some increasing return in the railway system that took me here 2 hours earlier than then, or 2.5 hours earlier? No, it was technological change. A different type of trains being used. It was costly to invent it. It was invented, produced, improved, and eventually, and so on. Okay, so anyhow, that's the point. But the point of, let me go back then to TFP. So yeah, so one view is, if you assume there are increasing return in the aggregate production, then the TFP exercise makes no sense. Because literally at that point, because you cannot measure directly the increase in return, given that labor grew 3% and capital grew 2%, you can say nothing about how much output should grow. Could grow 5%, 12%, 9.5%, who knows? But if there are no increase in return, then if one input grows 3% and the other 2%, output has to grow between 2 and 3. Between 2 and 3. If the two factors are both needed in production, as it is natural to think. And therefore, if I observe that year after year it grows at 4, I say something is going on. One answer is there is increasing return. Sure. You understand? Verdurn law is actually this. The so-called Kaldor thing is this. It's just reading TFP by closing your eyes and say, oh, there are increasing return in the aggregate. Solow said, that's what made him famous in some sense, made a very trivial Schumpeterian observation. I mean, this is not to put down Solow. I have a huge admiration of Bob Solow. He's a great guy. But the observation, in some sense, maybe in retrospect or after reading Schumpeter, was obvious because he did exactly the same exercise. If you read the theory of economic development, the first 2 chapters, without numbers, Schumpeter keeps saying there is no way you can get this growth in output by simply thinking of accumulation, by simply saying, oh, we saved a lot, we invested, right? So that's growth rate of capital. Or we have more workers, our workers are healthier, they work longer hours, blah, blah, blah. No way, he says. There's just no way you can get it. And he said, look around. You know, you have electricity at the time he started having, you know, you have all these different machinery. Clearly, that's the reason why we're so much richer than at the time of Smith and Ricardo. And Solow says the same thing. Look, guys, I've done this numerical observation, and when I subtract a weighted combination, he weighted capital growth by its share in national income and labor growth by its share in national income. And you all know the justification, but it's not necessary. You can use another weight. And every time I get a big difference, what he called the residual. And this residual is very big. There are many years in which this residual is equal to 90% of the growth rate in output. There is the two inputs grow very little, 1%, and output grows 10%. For example, Italy in the 50s, try to compute TFP anywhere you go, but especially in the private sector in Italy, try to compute Italian TFP growth in between 1947, 8, I think you get data, to 1965, and stick to the private and non-agricultural, but also agricultural sector in Italy. You'll get very big numbers, very big. And the reason was, yes, there was a lot of investment, but it was investment in new plants. People were doing new things differently. Okay, so that's the point of TFP. And that's it. Unfortunately, and we go back to the lecture on what happened is, I don't know, we kind of decided that because these numbers were behaving so nicely, and especially in the United States, this TFP index, because it's an index, right? There is, notice one thing, whereas capital can be used, it can be computed using base dollars of some year, with all the problem of chain index that you want, with all the problems due to aggregation that you want, but it's still, there is a unit, you can compute it. And hours, with all the kind of mistake you want, for example, in particular, hours you cannot compute. Our workers in 1962 are different from workers in 1961, 1960, 1959. So workers' quality also changed. But at least you have hours. TFP, there is no index. There is no quantity. There's not a meter, kilogram, liter, whatever, in which you can use TFP. So TFP is not relevant what the index is. In TFP, the only thing that matters is variation, right? You always normalize TFP at 1 in the first year of your sample. And then you compute its variation from year 1 to year 2, from year 2 to year 3, from year 3 to year 4, which is also what allows people to do it across countries, even if it is a bit riskier. You normalize TFP in a country at 1, you use, or 100 or 1,000, whatever you like. And then you compute its variation as you go from one country to another. Okay. And because it moved so regularly, people ended up concentrating on that. And in macro theories, in growth theory, to take it as exogenous. So they completely forgot what motivated, we completely forgot what motivated the initial work of Schumpeter first and then Solow, and decided to treat this magic number as if it had a life by its own, literally life by its own. And this has led to, in my opinion, a long list of not only mistakes, but also, how can I say, we somehow missed the point. We ended up not studying the problem deeply enough, and it was a problem that was worth studying. But I'll stop here on this because otherwise I go too long. So that's one view. So one view is the following: you measure TFP, you estimate TFP. Notice that you can estimate TFP for the macroeconomy, but you can estimate TFP for a sector, for an industry, for a region, or you can estimate TFP for a company. You can estimate TFP for a plant if you have the data. And in fact, here is what I've learned by doing it in very many cases, in very many instances by myself, with my students around the world. The more micro you go, the closer you go to a plant, the more you use data that say, okay, yes, we have 10 machines. Our capital is worth $7 million today, but it's composed of this type of machines. 7 are numeric control, 1 is a new assembler. Yesterday, we had capital that was worth about the same, but the numeric control machine was only 1. So we actually did not increase the cost total of the capital, but we change the machine. When you start putting in those data and the data about workers, then TFP disappears. Then TFP disappears. Statistically, econometrically, the problem becomes a lot more complicated. It's, let's say, it's an advanced econometric problem. It requires a bit of thinking every time, depending. But the interesting thing is that the more precise you get in specifying the changes in input, the more TFP disappears. Why? Well, because you're actually describing technological change at that point. You're showing that you're changing the technique. The person, he died before getting the prize and he would have deserved the prize. It was very smart, very interesting. The person that first showed this was actually not a student because they were almost same age, somebody called Zvi Grilikes, ZVI Grilikes. He was an econometrician specialized in agricultural economics, and his PhD thesis, I think 1958, took the data about agricultural output and productivity in the United States, and he had a lot of detailed data about seeds and change of techniques in the countryside, okay, in the farming sector. And he showed that with better data, you made TFP disappear because you were showing explicitly in the data that there was technological progress. So there is no doubt that even if the aggregate measure of technological progress, TFP, is very rough, horrible, terrible, okay, terrible. Don't ever get into a debate with a TFP says, oh, 1%, no, 1.5%, no, 2%. Who cares? Not relevant. What's relevant is if you have Italian TFP, there is no doubt you're stuck. Okay? Because if for 40 years you're flat or you go down, then the measurement can be as bad as you want. But man, when it is that bad for so many years, you see what I mean? And if instead it goes up a lot for 20 years, then you clearly are changing techniques. That's the point. So don't, the debates about decimal points or even 1% versus 2% in estimating TFP growth 1 year versus another, either you get very technical, which is true, good. If you're working, if you are one of the people estimating it and somebody points out to you that you actually could adjust some data and get a better estimate, absolutely. But if you're at the general level of a policy debate, debating 1.5 versus 2, I don't think it's important. It's important to notice that, let me actually show you, I suppose you all know how to find, do you all know where to find easily TFP data for, say, Italy or other countries? I need an, huh?
Actually, no.
Actually, no. So let's do this together. Let's do it together, even if we go late with class, it's okay, because you got to learn how to do this, because you can play with that. So here, you follow me, okay? Let's use Opera. You see this? All right, so let's go here. Let's go here. And let's go here. See, my computer knows that I look at that data often. So, Italy. Come on, baby. All right. Fred makes two sets of computer TFP available. One at constant national prices and one at purchasing power parities. They cover the same period, 5419, and they come from the same database, okay, which is word table, a Penn word table, okay. What is the difference? These are national prices normalized at a base year, in this case 2017, I think, okay. This one instead, purchasing power parities, adjust national prices for international prices in order to make sure that different relative prices of the same good, different absolute price of the same good in two different countries are canceled out, right? And they use USA as a reference price, right? So index, see. These are going to give you two different graphs. Italian TFP at constant national prices reaches its peak around 79.80, then goes down, up, down, but basically stay flat until more or less here. Then it starts going down after 2000. There's a big drop. Then it goes flat since 2012, right? But it's now about 0.99, and its maximum, it was 114. So it's 15% down in national prices, okay? So you see, it doesn't matter if it is 15, 14, or 13. Point is that it's since pretty much 74 that it's flat. And there's no doubt instead that the 20 years before, boom, okay? If you look at the purchasing power parities, the picture is even starker. Why? Because remember that this is when the devaluation, the famous mythical devaluation starts. Okay? You remember people says, oh, by devaluing we will grow? Yeah, sure, look how much. You do wonder if you devalue to, you know, so 1980 is the peak, the clear peak here, and then it's all the way down, okay? All the way down. And you see there's no really a difference between the post-Euro period, right, where there is a little bit of devaluation, and the pre-Euro period. Obviously, there are intervals of time in which, because the lira does not devalue, like here, in fact, it goes up a bit in those years. There is, the index goes up a bit, but, you know, here what matters is that you go from 1.2 to 0.7. Who cares about the other details, right? Whereas here you go from 0.6 to 1.2. So your index doubles in the first 25 years and goes down of 40% in the following 40 years. And interesting, moreover, what you can do is to do this. You take that and you go and add a line. And for example, you can add a line for Spain. Let's not do Germany. Otherwise, Germany, people say, oh, Germany. See, because that's another way of learning how things change, relatively speaking, in one country or another. Oops. Okay, so let's do current purchasing power. Add. Now the series there. Don't worry, you don't see it. Now we're going to add it. And now we're going to say, hey, do you want to go in? Okay, it's there. Now we're going to edit line. You see, now you can see the two lines. You see them?
Yes.
See, the red one is Spain, and that one is Italy. Now, the thing you want to do is to take the ratio. Okay, and then you do, let me take away here. No, get it. Oof, I'm already doing it, sorry. Oh, yeah, so A is Italy, right? And B is Spain, so I can do A divided B. Apply. All right, now we have to delete this. Look at that. This is now the ratio between Italian productivity growth and Spanish productivity growth. It tells you the story of the last 70 years in the two countries. So we were going much faster than Spain at the beginning. Notice here, You see, it's beautiful how data tells you history. You say, what happened there? This is 59. In 59, we go to one of the first peaks of Italian productivity growth with respect to Spain. After that, we go down until 65. You know what happened? Let's see if somebody can guess what happens. It's history. Well, nothing really happened in Italy. What happened was in Spain. Until 59, they started some reform in 56, excuse me. But until 59, Spain was in autarky. Was literally in autarky. In 59, they got out of autarky. They were starving. And they opened up a lot. And they started a period of explosive growth where they changed technology. There was a lot of import of new technology from abroad and grew. After that, they slowed down. And look at Italy, right? We did so much better than that until 1980. And so in 1980, our index went to 115, the highest level. After that, thank you to our beautiful devaluations, our beautiful public spending, all our miracles of the 80s, we started to lose productivity growth, and they kept going. Right? Then there was a little bit of a recovery here. Then there was a bad period for Spain. That's the crisis 2008, 2010, right? Italy did a little better until 10, and then bang. See, numbers can tell you, if you look at them carefully, can tell you history of two countries, not even one. All right. So that's the way that stuff works. Okay, let me go back to the shares, to the slides. I'm sorry. Okay, so that's enough for this topic. I know we could go on, and it's quite interesting. We could go on for the whole course on this, but I promise to teach something else. Now, there's another way of looking at technological change, which I think it's interesting. I think people erroneously think at what I call the general equilibrium Schumpeterian way, as opposed to this one. And people following this approach, I think they exaggerate how useful it is in understanding things, and they exaggerate how opposed it is, how different it is from, measuring TFP and asking why do the four questions I asked at the beginning, what, how, why, and when. So one can say, oh, technology, because it's an activity, those activities are like strings of a gene, are like a genetic code. And therefore, we can use the same logic that biologists use in studying genetic evolution, and think at technological change as a continuous process of mutation. And if you think of what I said before in pointing out that technological change takes place every day, every moment, in thousands of different instances in the world, one can think, well, that's a little bit like mutation, right? There are continuous genetic mutation of every kind of thing, not only of the COVID virus, also of all kind of genetic code around mutates, right? And lots of those mutations are random, okay, and are small. But because they're random and small, some of them disappears, have no effect. Some of them sometimes have big effect because they reproduce. They're very successful. And now there is a first difference that comes in. Because even if I assume that the entrepreneurs, or you and me, introduce the innovation randomly without thinking, we just do it because we do it. There's no really a good motivation. Then there is no doubt that in the genetic kingdom, imitation of a mutation is simply the fact that that type of code reproduces faster because it gives an environmental advantage. It makes more copies of itself. and it's automatic. In the economic area, when I observe that the bar next door has introduced happy hour with all you can eat, and that maybe it's random. Maybe the guy did it because one day he had a loft of tramezzini and pizzette left over, and he was getting close to the evening, and he thought, well, you know, there's a bunch of guys coming for spritz, and I have all that food today that didn't sell it. Let me put it on the bar and on the table and tell them that, you know, if they give me $2 more, €2 more, they can eat all that they want. Okay. And so the guy invented a pericena that now every Italian 20-year-old does, because it's an easy way to feed himself with and getting drunk with a few spritz and eat a lot of pizzette. Or not. And see, you're laughing. No? Well, I know these people doing it. So it might be, you see, that the guy that first invented a pericena did it randomly. But the guy that copied him, or the lady that copied him, didn't do it randomly. They said, shit, that works. Now I can say, well, Boldrin, what's the big deal? Still, it's successful, and that's the way it's successful. Yes, but it's another company doing that. And that's introducing competition between those two. Whereas if I make a copy of myself because the mutation I had is favored by the environment, we are competing with the other guys, different from us, not with ourselves. There are instances one can say, well, now the analogies get more serious. Well, depends. If it is a prey-predator model, right, as the number of predators increase, they decrease the number of preys, and therefore they're competing with each other. True, but that's not a model of mutation and imitation. That's simply a mechanical model of success, failure, prey-predators feeding on each other. And you can go on in any case. So as you go on, you realize that there are some aspects of this analogical model of technological progress as genetic, biological mutation, reproduction, evolution, survival of the fittest, etc., that seems to work to understand the economic mechanism, and some other that don't. And what is that doesn't? Intentionality. The why. It's the why. And so I don't know. I frankly don't know. I don't find it satisfactory. I remember in my own experience, very big discussions with very famous biology and other people at the time of Santa Fe 30, 40 years ago, in which they kept insisting, well, you know, at the end, if you just want to have a distribution of firm size, all you need is random mutation, blah, blah, blah. It says, sure, you do. You get the picture, but you're losing the human motivation. Because what I find it fascinating to understand about innovation, imitation in the economic area, and in fact in the human areas in general, because humans in some sense are always innovating, and I'm not sure you will be willing to put this always under the economic label, right? Artistic creation, food, lifestyle, dressing, sure, everything at a certain point may have an economic side, but many people refuse to see it in that way. And we do it intentionally, purposefully. We don't do it randomly and mechanically. There is, the biological analogy is very interesting because it allows you to see, for example, the fact that there is path dependence in some instances. You know, randomly, sometime one guy makes one thing new. He could have made another, but this new thing that was made is so relevant and so it affects the economic environment so much that it makes other innovation impossible, but other very easy. So it creates path dependence. And this also happens in the natural environment, so at the biological level, no doubt. But on the other hand, I find it not very satisfactory describing the process of innovation as random mutation plus automatic replicas of successful innovation. But anyhow, it's another point of view. Or it's not a different point of view. It's a point of view that tends to take away choice, intentionality, prices, and use prices only to the extent that they determine what's successful, what's not. And which makes it a bit funny, right? Because in the biological view, in the strict biological model of technological change, what is that you have? You have that profit maximization is an ex post selection criteria, because at the end, it becomes, there is a famous paper by Armen Alchian, in case you're interested, written in the late 50s. Armen Alchian in Italian, Alchian. Wrote a number of papers. He has a famous one back in the 50s that says it doesn't really matter that all the entrepreneurs are always trying to maximize profits. They may actually be doing other things. They may have other ideals or objectives. Point is that to the extent the production factors are scarce, that is, you have to pay labor, you have to pay energy, you have to pay intermediate product, and the prices reflect scarcity. If you don't maximize profit, well, you lose and you disappear. And so under a bunch of conditions, you end up being the one that survive and you maximize profit, okay? So that's an argument Arman elaborated, and I think it makes sense under certain circumstances. It's not so general as you may believe. There are other game theoretical settings in which you may survive even if you don't maximize profit. In any case, in that view, profits is an ex post selection criteria, right? If you make profit, you survive and reproduce. If you don't make profit, you don't survive, you don't reproduce. And this is fairly consistent with the biological view. My question is, are we sure that it's only a selection criteria ex post and it's not also an ex ante motivational factor? That is, are we sure that we have a better understanding of how firms and entrepreneurs and innovators and people in general behave in the business realm if we throw completely away the fact that they do intentionally things to try to make profits? I don't know. Just leave it there. This I already said before, so you can look at this, but it's so important for this. To close, I want to explain one little thing. Was there technological change before Schumpeter? Yes, there was, but there was very little. So one thing they all observed was that there was division of labor. But that was it. That's clearly another of the many proofs that economics at the end evolves according to what you observe in society, and then people theorize after the facts and not before. But for Smith in particular, that wrote about 50 years earlier, more or less. But Ricardo, Malthus, they all observed this growth in commerce and growth in the division of labor. They noticed that. But that's all they noticed. They didn't make it a theory of technological change. They noticed there was a growth in division of labor, which was technological change. And they tended to think that the bigger the market becomes, the more there is division of labor and vice versa. The first guy that actually, which I think is the reason why Schumpeter admired him so much, started talking about technological change very seriously and realized that it had become much faster, much more visible than in the past, was Marx. Marx doesn't use the word technological change. I don't even remember if he ever used the word. Maybe he does. Technical, he uses technical. He used the word development of productive forces. That's his terminology. He talks about the development of productive forces. He has a whole theory of history around the development of productive forces, okay? But what it means is technological change. And this is a good way of understanding one of the fact that it was way ahead of his time analytically. And for being a philosopher with no training in algebra and economics and so on, he was a remarkably clearer than other, and also got it wrong. Okay. And the way to see that he got it wrong is to think at a certain point he develops this little two-sector model. In fact, he's the first that is able to think. You may be interested that in some notes he has actually a six-sector model where he goes completely crazy because he's trying to solve a problem that he knows he's not able to solve. If at a certain point he gets all mad, he gives up. But he tries with a six-sector model, which is, a lot more than an average economist can do these days. Now, obviously, they didn't use symbols very much, and so you will find very little algebra in Marx, some little symbol, some addition. And he has these bad habits because, one of the reasons he gets confused is that he puts numbers. So he doesn't give a model, he gives an example. And he doesn't realize that some of the features of his example, you have to read it to understand. Some of the features of the example are due to the example, are not general properties. If he had put A, B, C, D, and he had put general restriction on those numbers, he would have realized that some of the thing he was finding was just not working for algebraic reason. And instead he uses number and he makes the number work, but he doesn't realize he's looking at special case. But anyhow, he has a two-sector model. One sector produces capital, and the other produces consumption. Consumption is consumed by capitalists and workers. Capital is purchased by the capitalist to create new capital, machines, okay? And he studies two cases. One of the simple reproduction, that is, you put in machines in one sector, machines in the second. That's what he called fixed capital. Then you pay workers with a variable capital that corresponds to their wages, right? The workers also, you extract surplus value. The surplus, remember, in Marx theory, surplus value is exactly proportional to labor value. It's, extra value only comes from labor, not from capital. The capital, the machine you put in is worth 100. That's all it contributes. It never contributes any value added, okay? Machine 100, machine 100. That's it. No value added from machinery, only from labor, and it's called surplus, okay? And so the total output of the first sector is the capital of the first sector, the labor of the first sector, and the surplus of the first sector. That's the total value the machines produced for next period that will go to replace the capital of the first sector and the capital of the second sector. In the second sector, you put the capital of the second sector, the workers of the second sector, the surplus of the second sector, that produce consumption goods. Those consumption goods go to feed capitalists and workers. So they have to be equal to the labor of the first plus the labor of the second sector, the surplus of the first plus the surplus of the second sector. That's simple reproduction, how the system reproduces itself, okay? Then he tries to build a model of extended reproduction, which capital stock grows. And there he gets all confused. Okay, he gets all confused. Why? Because the poor guy is trying to keep together. He wants to prove that the system has to collapse. Okay? And what is his argument? His argument is surplus come only from labor. Because remember, value added only comes from labor, right? So if there is surplus, the surplus is the exploitation, the surplus value, the one from which you get profits. So surplus has to be proportional to labor because it comes from exploitation. But the ability to exploit comes from capital. So that's the way he sees it. As the system evolves, the capitalist needs to increase the capital stock. Because if he increases the capital stock, he can exploit the workers more. And therefore, he can extract more surplus with which it can feed the new additional capital for next period. Okay? But because the capital replaces labor and the surplus comes from labor, this creates a contradiction. You're increasing the capital intensity of the system. To sustain the increasing capital intensity of the system, you have to produce more surplus, but you're actually killing the surplus, and therefore your rate of profit goes down. And that's what he believes to be the fundamental contradiction of capitalism that eventually will bring to a collapse. Okay? In fact, the contradiction did not realize. Now, there are a lot of reasons why the contradiction he predicted did not realize, and actually the opposite happened, because in order to predict the contradiction, what is that he said? He said, well, bear with me 2 minutes more, then we're done. Here's what will happen, he says. In order to exploit, the workers will be always kept at the minimum wage. All of them. Right? There will be generalized poverty. And even in spite of the generalized poverty, eventually the capital intensity will be so high that it will be impossible to exploit the workers so much to pay a good return to capital. So profits will disappear and the system will collapse. Now, this was wrong for a variety of reasons. He had problems with, as I said, you have to go read if you want to give you the references. It's very interesting to see how he tries to create a model of balanced growth. By the way, there is a literature by economists in the 50s that put Marx in order. There is a very beautiful book by Michio Morishima, was a Japanese mathematical economist that loved Marx and corrected the old model and made it work. He has the problem called transformation, a lot of things. In particular, he didn't understand that workers would get a share of value added that made their salary go above subsistence, and that would make them less prone to destroy the system. Okay, but the interesting key thing is Marx missed technological change. Why? Because he kept thinking that technological change has to imply more and more capital and not better capital. In other words, he kept thinking that in order for you and I to communicate by using computer today, our computer should cost $30,000 or actually $3 million, because it's 1,000 times more potent than the one I used in 2011 with Zoom. And it's not true. He just missed the nature of technological change. He didn't realize, and this is not to make him to say, given the periods and what he knew, the guy was already seeing a lot. The thing he missed was the technological change made machinery a lot cheaper, and a lot more productive. The technological change was labor saving, but the way in which it was labor saving was by making simpler, more complex but less expensive machines producible by better human capital. And that while it saved on labor, it also increased its productivity enormously. And the cost of increasing productivity enormously was going down. If you look at the relative price of capital, ever since, it just goes down. And therefore, this allows you to have a very capitalized society in the sense of a lot of machinery, a lot of very productive machinery that in fact don't cost enormously. And therefore his problem that, K is so expensive that even if we exploit workers at the maximum, we still do not earn a rate of profit, that prediction collapse. So it's quite interesting because his prediction collapses basically on the fact he doesn't understand the nature of technological change. And again, this is not a big criticism because at least he sees technological change. Nobody had seen it before him. Nobody had seen technological change as clearly as Marx did. He clearly notices that that's one thing that is characterizing what he calls capitalism, and he doesn't understand that it is one stage of economic development that comes after, science has been made independent, the steam engine has been invented, blah, 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 right? And it's nothing to do with capitalism per se. So he notices that this very fast technological change will make a difference. He insists that that's very important. but he thinks it will lead to a disaster because it doesn't make machines cheaper. It makes machines more expensive. Time for dinner. I'll see you Tuesday in class. Thanks, you guys. If there are questions, send me messages. There are references in the syllabus, so I didn't find it, so you can go read those. Take care. Good night.
Thank you.
Bye.
Thank you. Bye.
Arrivederci.
Bye.